Hi, we are now doing question 2 of November 2022 question paper, right? So if you are new here, please make sure that you subscribe and like the video. Also engage with us in the comments, right? So we have done question 1. If you have not done question 1, if you have not watched the video of question 1, please do make sure that you check it out. Okay, so without any further ado, let's get to it. So let's read the question. Okay, the question says the first term of a geometric series is 14 and the sixth term is 448. Okay, so we have the first term. Firstly, the geometric series is Tn equals to AR n minus 1, where A is the first term and R is the constant ratio, and then n will be the term position. Okay, so now that means the first term it's A, and then we are given that it's 14. So the value of A is 14, and the sixth term that talks to T6. Sorry, that talks to T6, right? So now, how we can then do this thing? We then say that T6 equals to, what's the value of A? Is 14. 14 R n will be 6 minus 1. Okay, so now now T6, we are given that it's what? We are given that it's 448. So 448 equals to 14 R 6 minus 1 will be 5. Then divide by 14, right? 448 divided by 14 will be 32, equals to this, and that reaches to 1 R power 5. Okay, so 32 can be written as 2 power 5 equals to R power 5. Then you multiply these exponents by their reciprocals. So it will be multiplied by 1 over 5, multiplied by 1 over 5, therefore 2 equals R, or R equals 2. That's the value of R. Okay, now going to 2.1.2. 2.1.2 says what? Says that determine the number of the consecutive terms that must be added to the first 6 terms of the series in order to obtain the sum of blah 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 blah. All right. Just take this question as they are looking for the value of n, being given that the Sn of a geometric series is given by Sn equals A into R power n minus 1 all over R minus 1. Okay, so just take it as they are looking for the value of n. Okay, so then Sn being this value there. Okay, Sn being that value, look for the value of n. Okay, A, you have your A, it's 14 here, right? The value of R, you just calculated it, you got it's 2. So what you are looking for is n. So now, my friend, just then substitute your value. Say 1 1 4 6 7 4 equals, the value of A is 14 into R. What's your R? It's 2 exponent n minus 1 all over 2 minus 1. So definitely you know that 2 minus 1 will be 1. So this thing is still the same as 1 1 4 6 7 4 equals to 14 2 exponent n minus 1. Okay, so you are going to divide by 14. Divide by 14 to remove that 14 there. So you have 2 exponent n minus 1 equals to what is now 114,674. 114,674 divided by 14. So there will be 8191. Okay, so then you take this you take this one, transpose it to the other side. 2 exponent n equals to 8191. Then plus 1, it will be 2 there. Okay, right. So now this is what you have. Then what you are going to do, you'll write this in an exponential form. So 8192 can be written as 2 exponent 13, 2 exponent 13, 2 exponent n. The bases are the same, you drop the exponents. Therefore, n equals to 13. Okay, that's it. Moving right along to 1 point, do this. Moving right along to 2.1.3, sorry, 2.1.3. If the first term of another series, the first term now of another series is 448 and the sixth term is 14, calculate the sum to infinity. Okay, we have the first term, and you see it's 3 marks. We have the first term of another series, of which is now the first term is 448 and the sixth term is 14. Okay, now calculate the sum to infinity. Okay, so now again, Tn equals ARn minus 1. So you still need to find R. Okay, the first term now is 448. 448 R exponent, now 6 for sixth term, 6 minus 1 would be 5. So now you have 14. Okay, so now what is it that you are going to do? You are going to divide by 448 divided by 448. So here will be 1 over 32 equals to R exponent 5. 1 over 32, since 32 can be written as 2 power 5, then 1 equals to R power 5. This can be written as 2 power negative 5 equals to R power 5. Now again, if now you have this, you can multiply by the reciprocal of 5, of which will be 1 over 5. Therefore, 2 power negative 5 times 1 over 5 will give you negative 1. Negative 1 equals to R. So this can be written as 1 over 2. So R equals to 1 over 2. Then now you proceed. You have the value of R. The sum to infinity is given by A over R minus 1. Okay, so therefore the sum to infinity for this will be the value of A, we said what? Would be 448 over R. What's the value of R? 1 over 2, then minus 1. Okay, so then you are going to punch this on your calculator and you get the sum to infinity. Or since the value of R is 1 over 2, Sn equals A over 1 minus R equals to 448 all over 1 minus 1 over 2. That actually would be your sum to infinity.